All right, welcome to our last set of notes for this unit. We're going to keep working on imaginary numbers and simplifying radicals, but part 2 is basically applying it to everything we've learned so far. So let's talk about why we care about imaginary numbers and having to simplify radicals. First of all, there is this exponent x-intercept rule that says the following. The biggest degree on a polynomial is how many x-intercepts there are. So the word degree means exponent. Oops, I used the wrong version of there. There are. How many x-intercepts there are. So basically, there's all these different types of equations, like a linear equation. I'm over in Desmos right now, the graphing calculator. So the nice thing about Desmos is that you can use it to graph things. So a linear equation is an equation that makes a straight line, like 3x minus 2. And if you see over here on the graph, it's just a straight line. The exponent here on x, because there is no exponent, it's like this invisible 1. So like if I did a little exponent of 1, it doesn't change it. It's the same graph if you look. And so with an exponent of 1, as you can see, it has 1 x-intercept. It crosses this x-axis once. However, if I make it an x squared, now it creates the parabola shape we all know. And it goes through the x-intercept twice, once right here and once right here. Watch what happens if I make it an x cubed, for example. Let's see. Got to put a couple other terms in there. Oh, yeah, look at this one. So this x cubed goes through the x-axis once right here, again right here, and again right here. That's 3 times because the biggest exponent you see is an x to the power of 3, even though this x to the power of 1 is right here. However, remember, without this 6x, this is still an x with an exponent of 3, but it only goes through here once. Even though I just told you the rule was if it has an exponent of 3, that means there has to be 3 x-intercepts. Well, this is where imaginary roots come in. It just means the other 2 roots are imaginary, and they're on the imaginary axis. It's hard to think about the imaginary axis, but think of it as a line that goes straight through the computer and makes this 2D picture become 3D. And so those roots are on the imaginary axis, as interesting as that is to think about. It doesn't really matter. Just know that there's always 2 x-intercepts, even if your quadratic looks something like, I don't know. So this one, it has no x-intercepts when you look at it. It's above the x-intercept line. It's going up and it's above it, and it doesn't cross this x-intercept, but this x-axis. However, if you were to use the quadratic formula, you would just end up with negative roots, or negative under the square root, which would give you imaginary roots. So that's why you can always solve for your x-intercepts. It's just sometimes they end up being imaginary, and they don't actually cross the x-intercept. They're crossing on the imaginary axis. So imaginary roots on the graph, as I was explaining, is instead of the x-intercepts being on the x-axis, they are on the imaginary axis. All right, so in everything we've learned so far, there are 3 different types of questions that they might ask you to leave your answer in radical form, this part right here. So on the test, sometimes they want you to solve it all the way and put it in a calculator and get a decimal as your answer. Sometimes they want you to leave your answer in radical form, which is why you have to know how to simplify radicals. So I'm going to show you the 3 types that they might use this phrasing on. And you just have to pay attention on the test. Like, you have to be paying attention. Is this one that wants me to take it all the way with the calculator to the decimal, or is it one where they say leave it in radical form so you don't? So we're going to start with this guy here. So simply, all this instruction says solve the quadratic equation for x from vertex form. It's already in vertex form. Both this one and this one are already in vertex form. So we just solve from here. Okay. So I'm going to go ahead and draw my line at the equal sign. And then the first thing I do is get rid of the one that's not with the x. So the 3's with the x, the squared's with the x. They're all connected with no pluses or minuses. But this says plus 5. So that's the one that's furthest away from x. So we get rid of it by saying minus 5. And I also have to do it on the other side of my line to keep my equations balanced. So now, on this side, I still have 3x squared. Three squared. But the plus 5 minus 5 canceled and went away. And then on this side, 59 minus 5 is 54. The next thing we get rid of is this 3. To do that, we're going to divide both sides by 3, because 3x squared means it's 3 times x squared. And so to undo multiplying, we divide. Dividing both sides by 3. So 3 divided by 3 just becomes the 1x squared. I don't have to write the 1, so I won't. And then 54 divided by 3 is 18. Yay, mental math. Okay. So then finally, to undo x squared, remember you take the square root of both sides. So if I square root this side, square root this side, the square root and the squared cancel each other because they're inverses, they undo each other. And so on this side, I'm just left with my x now, which is what I wanted. On this side, it says the square root of 18. So this is where, if it did not say leave your answer in radical form, you could simply come to your calculator and write square root of 18 and put that decimal as your answer. However, that's not what they want. They want it in radical form, which means I have to simplify this radical. So remember the square root of 18? Let's see. If I divide 18 by 2, I'm left with 9. Then 9 can't not divide by 2. The first 2 is still there. But 9, if you divide it by 3, you get 3. Now there are 2 square roots under, or 2 3's under that square root. So they can combine into 1 and come out front. So then my answer is x equals the square root. Remember, the 3 comes out front, so 3 and then square root of, and the 2's left on the inside. So 3 square root of 2 is the same thing as root 18. So if I came here and typed 3 square root of 2, look, it gives me the same decimal. All we did was simplify this into the most simplified version. And that is how you solve, but then leave your answer in radical form instead of decimal form. All right, let's do this one over here, which is just a little bit harder. So that's why I added in the example. So I'm going to draw my equal line at the equal sign. So when you have all this, to decide what to get rid of first, this 4 is getting times to the parenthesis with x. So I can't get rid of it yet. This negative 5 is in the parenthesis with x being squared, so I can't get rid of that yet. This minus 1 is the one furthest away, so it's the one we get rid of first. So we're going to add 1 to both sides. So then I have to bring down my 4, x minus 5. And then squared. And then it's going to equal, if you owe me $49 and then you get 1, you're going to be owing me $48. Writing on the computer is so hard. Okay. So now the next one, the -5 is in the parentheses being squared. But so that can't go away yet. But then the 4 is just getting multiplied to the parentheses. And it's being multiplied because there's no plus or minus right here. So then to undo it, I need to divide both sides by 4. I'm going to use red because this -1 plus 1 canceled. This 4 divided by 4 becomes a 1. That cancels. So then I still have x minus 5. In a parentheses, that's being squared. And then equals -48 divided by 4 is negative, because a negative divided by a positive is negative, 12. So then, now the -5 is stuck in the parentheses getting squared. So I have to undo that, unstuck this part, this parentheses, by taking the square root, because that's how you undo squared. So if I come over to my red, the square root and the square cancel each other. So then I'm left with x minus 5. Yeah. So I still have x minus 5. It's not stuck in the parentheses anymore. It's going to equal the square root of -12. However, because we're going to keep it in radical form, I'm going to break this down. So 12 divided by -1 is still positive 12. So I'm going to bring out the -1, and then the 12, if I divide it by 2, it becomes 6. And then if I divide 6 by the 2, it becomes 3. And then I'm down to all prime numbers. So anything that can come out should. So on this side, I still have x minus 5. And it's going to equal. Now the square root of -1, remember, gets to come out as an I. Show up. I. And then there's 2 2's under the square root that can combine into 1 2 and come out front. So I'm going to put the 2 in front of the I, because usually numbers come before letters. And we have the square root and left in here, so the -1 came out, these 2 2's came out, but I still have 3 in there. And then finally, I still have x minus 5. So to get rid of the -5, I can now add it away to both sides. So 2i root 3, and then I need to add 5. All right, and then for both of these, I forgot that it's not just the positive version, it's the positive and the negative version. So you want to put the plus minus sign to say it's both the positive and the negative. So I've been using this symbol. I'm not sure if I explained the symbol, but plus minus means there's 2. There's the positive and the negative. So I could write it like this, or I could have said 3 root 2 and -3 root 2. However, mathematicians like to be lazy and they don't want to have to write the and the whole expression again, so then they just write the plus minus in front to say both, talking about the positive and the negative. All right, let's do the next one. Boop, 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 boop. Oh, here, enter. So then Another way this can show up is they can say solve for x-intercepts when in standard form, leave your answer in radical form. So this is almost in standard form, but this is another way that makes this a little bit harder, is because remember, to solve for x-intercepts, it means it's on the x-axis. And if you just quickly remember, if it's on the x-axis, this one, it means that y is always going to be 0 if it's on this line, because things on this line don't go up or down. And this does not equal 0, because remember, y is usually what you equal. This equals -2. So it's really easy to fix. And all you have to do is, I want it to say equal 0, not equal -2. So to make this become 0, I just add 2 to my other side. So then my equation ends up being now 3 squared minus x, and then plus 2. Now it equals 0, like I need it to. So the reason why that 2 didn't go with the x or the x squared is because they're not like terms. It's the c, it's the number that's by itself. So it just gets added to the end. So remember, if you're trying to solve for x-intercepts when you're in standard form like this, you need to use the quadratic formula. So the quadratic formula requires you to pull out your a, which is the number in front of x squared. So in this case, it's 3. Your b, which is the number in front of x, which in this case is a -1, because it's like this invisible 1. And your c, which is a number by itself, which happens to be 2. And then we throw it in the quadratic formula, which says negative, oh, give me 1 second, turn it blue, new equation, it's a fraction. All right, negative b, ooh, this is tiny. All right, negative b, and b happens to be -1. Don't forget you need both of those negatives. Plus minus for the positive negative, square root of b, which is -1, squared, minus 4 times a, which is 3, times c, which is 2, all over 2 times a, which is 3. So that's the quadratic formula. I just happen to have it memorized, and I plugged in the numbers as we went. So then the next step in the quadratic formula is to simplify under the radical. So under here, I want to make it one number. This is the point in time where I know if I'm going to have real roots or imaginary roots. Because if under the square root it ends up being positive, then it's going to be a real root. And if it's going to be negative, then it's going to be an imaginary root. That needs the I. So -1 squared means -1 times -1, which just happens to become +1. And then -4 times 3 is -12, times 2 becomes -24. So I knew from this step that this was going to be imaginary, because 1 squared is way tinier than whatever this is going to be, because 1 times 1 is just 1. And because I'm minusing it, because there's only one negative. If this one was negative, then I'd be plussing, and then plus would make this positive here if it was a plus. But there's not a negative there. There's not 2 negatives. There's 1, which means we're going to be minusing, which means I knew from right here that I was going to have imaginary roots. Then finally, you do the 1 minus the 24, and you're going to get -23. Because if you have $1, but you owe me 24, you're going to still owe me 23. If I do some more simplifying, this negative just becomes a +1. So I can get rid of that. And this 2 times 3 becomes, becomes 6. So now I'm at a point where if this wasn't leave your answer in radical form, all I do is I'd go here and I'd do the square root of 23. And I'm doing positive, even though it's negative, which is 4.79. So then this would equal and don't write this down because this is an if this wasn't here. Square root of negative 23 is 4.79, and then the I, because it was negative. So I can't combine the 1 with the i's because these are imaginary, and I can't combine the 6 with the i's because they're imaginary. So this would be my answer. It would literally be my two answers. Look something like so remember, if they're asking for the root, what they want is a whole point. So it's this, but not plus minus. So there's 1 with the plus. And when you plug that in, you're going to get out 0 because it's an x-intercept. And then again, but this time with the minus. And then comma 0. And that's your second x-intercept. Now this is what you would do if it did not say leave your answer in radical form. However, they want you to leave it with the square root, not with the decimal. So instead, we're going to try to break up negative 23. Here's the important part. The negative 23, here. Will break up a little bit. All right. Just do it this way. Will break up into negative 1 and positive 23. Then, if I just check my prime number list, oh look, 23 is on it. You can't break 23 apart anymore. So the only thing that's going to happen is this negative 1 is going to come out and become an I. So it's going to equal okay. So the negative 1 comes out as an I in front of the root. But root 23, you can't break apart, so it just stays as root 23, which means what they want here instead of the decimal is they want this, say, plus I root 23 minus I root 23. And the rest of the fraction needs to be there as well, comma 0, everything else, but that's basically the difference, is that if it doesn't say leave your answer in radical form, you would throw the positive 23 into the calculator and figure out the decimal. Or if you could have broken down 23 further, you would have, but we can't, so that just ends up being our answer. Those are the two x-intercepts for this equation. All right. One more. So this one, again, it says solve for x-intercepts with completing the square, and then solve for them from vertex form. So this one's a bit complicated because they want you to double step it. First of all, it's almost in standard form. The reason why it's not is because it doesn't say equals 0. So to fix that, all I gotta do is add the 40x because it says minus 40x, so I'm gonna add it this side and to this side, which means my equation becomes 4x squared. The x term, the 40x is my b, so that's going to go in the middle, and then plus the 800. And now it equals 0, like I need it to. So to complete the square, remember first, I'm going to just take this and separate that plus 800, not think about it for a minute. Then I need this to not have a 4 in front. I need it to just be an x squared. So to do that, I divide out the 4. from my first two terms, because I'm only thinking about it. So if I divide the 4 away from the 4, it just becomes 1x squared, which is what I want. And if I divide 4 out of 4D, it becomes 10. And then the plus 800 at the end. We'll think about that later. So now working with just this guy, if you remember from completing the square, and if you don't remember completing the square, go back to that lesson because it's really important. Remember, this becomes just the x instead of an x squared. This gets cut in half. And now this parentheses gets squared. And this is almost the same as this, almost. However, if I multiply this out, x plus 5 squared, and I'll just quickly do this on the side to remind you. But if I were to multiply out x plus 5 squared, that just means I have 2x plus 5 parentheses. And then, so if I multiply that out, the x times the x becomes the x squared, which is what I have right here. The x times the 5 becomes a 5x. And then this 5 plus x right there is another 5x. And the two 5x's together become 10x when I add them together. And that's what's right here. But then I have to do the 5 times the 5, which happens to be 25. That 25 is not up here. It's not over in my parentheses. So it's almost the same thing, except I'm secretly adding this plus 25 by changing this into that. And it's not just 25, because there's this 4 in front being multiplied to it. So there's secretly a 4 right here in front, which means there's a 4 in front of all this. So when I multiply 4 into everything, that becomes 4x squared, which is this guy right here. This becomes 40x, which is this guy right here. But then this 4 times 25 becomes 100, and that 100 does not exist. So this is secretly adding in 100. If I'm going to secretly add in 100, I need to subtract out 100 to keep it balanced. So with that being said, I now have 4x plus 4x plus 5 squared. And then this part, the plus 800, and then I'm going to minus 100 from it, is going to become plus 700, and it equals 0. And now I am officially in vertex form through completing the square. Again, that was lesson 2, but that's completing the square. So that's step 1. I solved for x-intercepts with completing the square. But then it says, and then solving from vertex form. So I still have to solve this for x. This takes it back to type 1, where it's like I'm in vertex form, I just need to solve for x. So to remember to do that, first thing I get rid of is this plus 700 by minusing it away. Gotta do that on this side too, which means I have 4 plus 5 being squared. However, this 700 minus 700 cancels, and they're gone. So then I'm left with 0 minus 700 on the other side is negative 700. So now I have to get rid of the 4 that's being multiplied by dividing it away. Divide 4. So this side, the 4 divided by 4 cancels and turns into just 1. Then I'm left with parentheses, x plus 5 still, being squared, equals negative 700 divided by 4. Oops. Is negative 175. So now, to get rid of the squared, you do square root to both sides. And on this side, it just cancels the squared. But on the other side, so we still have x plus 5. Now it's going to equal the square root of negative 175. So because, again, if they didn't want me to leave it in radical form, I would just type in the square root of 175, positive, write that decimal, write the I, my plus minus, and so my answer would end up being something like x equals, what was it, 13.22 plus minus 13.22 I, and then I'm going to have to subtract the 5 away to get rid of that plus 5. So that's basically what the answer would look like if they didn't want you to leave it in radical form, but they do. So instead, we're going to break apart this radical. Oops. So negative 175, first of all, can split into negative 1 with positive 175. 175, any number that ends in 5 can divide by 5. And 5 is a prime number, meaning you can't split it apart anymore. And so I know that 175 can divide by 5. And if I do divide it by 5, I'm left with 30. Oh, well, 175 divided by 5, 35. So again, 35 is a number that ends in 5, so I can divide 35 by 5 again. When I divide 35 by 5, I'm left with 7. And 7 happens to be a prime number. You can't break it apart anymore, just like 5. So this is as broken apart as possible. So there are 2 5s. These 2 5s can combine into 1 5 and come out front. So I'm going to delete it from inside and bring it out front. Also, the negative 1 can delete and come out front as an I. And then 7 is left under the root. And then don't forget, because it is a square root, you have both the plus and the minus. And finally, to finish this up, it's just x isn't quite alone yet. We need to minus the 5 from both sides. You can't subtract this imaginary number with this real number, so then they're just going to look separate. So then I will have 2 answers. Yeah, I guess I'll do it down here. So my first answer is parentheses positive 5i root 7, and then comma 0, because it's an x-intercept, which means it's a point where the y is 0, and, oh, I forgot to write that I'm minusing 5 at the end of that. Now, make sure that this minus 5 is not under the square root. If I typed it right here, see how that house, the line, keeps going under? That means that they're both under the square root, and then that actually becomes the square root of 2, because you would do 7 minus 5. But it's not under the square root. It's after the square root. And so then I made sure that the house did not continue over that negative 5, because that negative 5 is a real number that's separate from this imaginary number. And then there's also the negative version of this. So it's not this minus 5 that changes the sign, because that came from this plus 5. And that's just the end. I'm just subtracting it away. what was both positive and negative was this front part, because when you take the square root, it becomes both positive and negative, which is why it's positive here and negative here. And that ends up being the answer to that one. So, like I said before, sometimes they might ask you if quickly to determine if the equation is going to have real roots or imaginary roots. Please note here that I wrote imaginary / complex because complex is just another word for imaginary. So sometimes a question might say, are the roots complex? And that just means, are they imaginary? So the part of the formula that tells you this for the quadratic formula is always under the square root. So the formula is negative b plus minus the square root of b squared minus 4 times a and c. And if this ends up being negative, then they're going to be imaginary roots, complex roots. And if it's positive, then we'll have real roots. So some quick ways to think about it is like, let's say my A is 5 and my B is 2 and my C is 3. Okay, in this situation, it's going to be imaginary because the b squared, this first number, b squared 2 times 2 is just 4. So if b squared is just 4 right now, minus a positive, because 4 is positive, A is positive, C is positive. 4 times 5 is already 20. Times 3 again, 60. So if I'm just going to do 4 minus 60, definitely going to be negative. It's going to be an imaginary / complex roots because this b is so small and I am minusing bigger numbers when they get multiplied. 4 times 5 times 3 is just going to be a lot more than what b squared is. However, let's say this a was negative. But then the two negatives would make this a positive. And then when I add them, 4 plus 60 is just positive 64. So that would make it become real. But then let's say C was negative. Now this one has a negative 4 times a negative is positive, but times a negative again goes back to being negative. So that it goes back to minusing, taking it back to negative / imaginary / complex roots. And so that is the really quick way to figure out if your roots are imaginary / complex or if they are real.